Hello everyone, my name is Yi Ming.
My name is Hoong.
I'm Jen Seng.
We are students from UMP Pekan.
So today we will talk about projected motion by using our C programming.
Let's get started.
Yeah. Okay. Hello everyone. Our objective is find out the projected motion for the displacement, height, kinetic energy and potential energy, and also the time. First, we will write the file name. The stretch and star is so that we write the stretch and star so that the computer will not read it. After that, we will list out all the header file. The stdio.h stand for standard input and output. Math.h is used for the sin s cos s for the mathematical calculation. chblock.h is for graph, and then we also need to define the n equal to 100 and mg 9.81, which is the gravitation g. After that, we will write about the function. All this is function, and then double means the return type. Then the result will return out the result will return as double. For example, the answer will come out with decimal numbers. The h velocity is the function. Double v and double a. This one is the argument, but it is in the double. That means they are in the decimal numbers. This one double s is the output. S equal to v star cos bracket a slash 180 star m slash pt. This one is the statement for the star, right? In the computer programming, we need to put a star. Star means times, and then slash means divide, and then return s means return s is for us to call back in the main function. So all these have all is the same, is also a function, but for the double height they have three arguments, and the potential have 4 arguments. Every complete sentence we need to put semicolon. We must put a semicolon so that the program can run it. For the main function, we need to declaration. First of all, we need to declaration all the unknown. Doubles means the decimal place. Integer means the number is without decimal place. For example, is 1. It don't have any point. CHRJ means character J. Cplot means for the graph. Loop 1 is a loop for the while loop. After we key in, after the finish, they will ask, do you want to restart? If we put the 1, we will automatically come back to here. So let's talk about the printf. Then we will put the loop equal to 1 for the letter we further looping. Bring later we want to ask the user to insert the mass of the object. So we will printf. Welcome to the program of the projectile analysis. First, please input the mass of the object in kg. Scanf specifier LF. Specifier LF means the users can put the numbers with in the decimal numbers, and the M means for the N is save the number. For example, if the user put in numbers 3.0, then the M is equal to 3.0. While M smaller than or equal to 0, they will come through here in valid input. We set the while loop because the M, that means the mass of the objects, will never get smaller or equal to 0. So if it is smaller or equal to 0, they will come up invalid input. So they will call the user to please re-enter your mass of the object in kg. They want the user to re-enter the number of the mass of the object until it is not smaller or equal to 0. So scanf again, save the input again, and then after it is not smaller to or equal to 0, they will come to the next line. They will ask again. Now we want to ask about the velocity. So now again we will ask the user, now please insert the value of the velocity, positive value, in the meter per second. Scanf, we save the data for the users while v smaller to 0. Here we mentioned that velocity that we use must positive value. So here at the while loop, v must be, if the v smaller than 0, then they will come up invalid input. They will ask the user to input the velocity until it is more than 0. So input again, scanf again. So and then lastly, we will call the users to insert the angle of projectile in degree, positive value. Scanf again, input user input again, and here the angle A must be acute angle must be between 0 and 90. So if the angle is smaller than 0 or bigger than 90, it is wrong because it's not a angle of projectile. So they will come out of invalid input. So they will ask the user to re-enter the acute angle again until they get the correct angle, which is between 0 and 90. So they will save the data at the scanf here, and then they will calculate the t by use this statement, and then find the big T. Then we will come to the while loop equal to 1. Here we will come to the value of mass. This one is to show the users again, the user what is the number that user put in input just now. So they will come out the value of the mass. 0.3 means the decimal only 3 decimal place. For example, 3.0332 with 3 decimal place, and then the value of velocity, they will come out all again, and then here they will come out printf again. Now please select the data need to calculate. Input the number of for the item to calculate. They will ask the users to wish to here we will ask the users to choose one more, select a data so that we can calculate one more item. So here we got printf. First one is the displacement, second one is the height, third one is the potential energy, fourth one is the kinetic energy. Users can choose any 1, 2, 3, 4 here, and then we will save the input.
Okay, hi everyone, just now my friend explained about scanf for C. If the user key in C for equal to 1, it will come to the else if looping. If the user choose C equal to 1, it will come to the first statement, which is calculating the displacement. So to calculate it, we use x equal to h velocity, which is the function that been shown just now. After that, we use d equal to x times t, so that we're able to calculate the furthest distance. So that after we calculate it, we use printf. We print the furthest distance d equal to the number that we calculate, and then after the user use to print out to show the user the distance. After that, we want to construct a table. We use printf t time t distance s, and then we printf a line. After that, inside the table, we'll use a for loop. For the for loop, we let k bigger or equal to 0, but k have a limit from less than t minus 0.1, so that the k won't overlap, or the value won't be bigger than t. So for the looping, k will be equal to k plus 0.1, means that the k will be increased 0.1 every time we loop. After that, we calculate the s, means the distance over time. When the k increasing, the x will remain constant, but k increasing. So that when we printf, we were able to print out the increasing data of s, means that the distance. For the printf, we use specifier 10.3f, means that you will have a 10 spacing at the front, and then 3 decimal place for f, for the first f, which means is the k, which means that for the user will be known as time. After that, we use specifier 16.3f. This one is for distance, and then it have 16 space at the front, and then 0.3 decimal places for distance. Now, the completing of for the c equal to 1. If the user choose c equal to 2, we're going to calculate height. So that when you come to the looping, if the user choose c equal to 2, it will come to the second statement, which will be calculating the height. To calculate the height, we use y equal to v velocity, same as just the first statement. We use the function that we declared when at the early of the program, and then we use h equal to power y, 2 means that y power of 2, and divided by 2m underscore g, means that the y squared divided by 2g. The g means gravity. After that, we're able to printf the maximum projectile height, means that after we calculate it, we're able to printf the highest maximum projectile height to let the user know the data. Same for the first statements, we want to construct a table, so that we printf the time and the height, and then we put a line. After that, we use the for loop. For loop, we same as the first one, we use k bigger or equal to 0, and then k less than t minus 0.1, so that the k won't be more than t. And then here we use the same, k equal to k plus 0.1, so that the k will continuously increase 0.1 every time we loop. And then the height, we use function height vak, means that we will bring the value of v, a, k to the function, and then to calculate it, so that to let the user shown to know the data, we use printf to print out all the data we calculated. So for the looping, we will continuously printf until k exists t, and then we put a line to end to complete the table. So this is complete for c equal to 2. When the user at the first choose 3 as means the potential energy, the program will directly go through else if c equal to 3, means that we're going to calculate the potential energy. When to calculate potential energy, we use y equal to v velocity as a function we declared just at the early of the program, h equal to height at the function, p equal to potential also is a function above before we start the program. So as same as the c equal to 1 and 2, we also want to create a table to let the user more understand and more clear about the data. So printf time t potential energy and the line, and same here we use k for the for loop, and then the p use the function p potential, and then we printf every increasing data for the k until the k less than t. Until after that we draw a line to complete the table. So this will be same if the user choose 4 kinetic energy for C, so that it will use the x equal to h velocity function, and then we'll printf the kinetic energy and then the underline, and then you'll use the for loop to calculate capital K equal to kinetic, and then printf the data until that k exists t. After that, we printf a straight line to complete the table. Let's say if the user enter the value not from the choice, means that not 1, 2, 3 or 4, the program will directly go to the else, which means that we'll let the c equal to -1 and then printf the invalid input, and then need the user to please enter the choice again, so that the user have another chance to re-enter their choices. After the user re-enter the choices, the system will directly send the user back to the HAI, means that we stayed at here, so that the user able to run back here and then let the system choose again what the user want to choose. After completing the table, we're going to go to the printf, the next statement. Do you want to plot a graph? And then the printf enter 1 for yes, 0 to n. And then we use a scanf and locate it as I. If I equal to 1, we're going to let the user to choose the graph that they need to plot. So we printf, please select graph to be plotted, and then to let the user to understand what choices they have, so we printf the option. So we printf 1, graph of height against distance, or printf 2, graph of kinetic energy and potential energy against time. And here we put a scanf specifier dj. Specifier d is for integer number, and then just now at the top we declare that j is a integer. Let's say if the user choose j equal to 1, we let sg0 equal to 0, and then tg0 equal to 0, means that the distance at initial we put 0, time equal to 0, and then the t final we use a formula to calculate the t final for the projectile, means that the total time need to travel for the projectile travel. SGF is the final distance traveled by the projectile motion. So same as the TGF, you have a calculation need to calculate. So that for here we want to calculate. For here you want to calculate the distance traveled against time. We use the for loop. For here, we let q equal 0, q less than n. Just now we declare that capital N is equal to 100. And then Q++ means that every time looping, Q will be increased by 1. And here we use array TGQ equal to the initial TG0 plus Q times TGF minus TG0 divided by n minus 1. Means that we're going to save the time travel increasingly until Q achieve 100. This will be same for SGQ. The program will going to continuously save the SGQ until the Q achieve 100. And then HGQ means that the height travel. We'll also use the formula to calculate it, and then we use the array TGQ for just now, so that the HGQ will be saved for different number. Means that HG1 maybe will be different with HG2 and HG3 and so on. After we save all the array, we use plot XY to plot a graph. SG is the x-axis, HG is for the y-axis, and the n is for the number of points for the graph. And then height against distance, this one is a title of the graph. Distance is for the name for the x-axis of the graph, and the height is for the y-axis of the graph. Let's say after plotting a graph, in case at the initial the user choose 2, the graph of kinetic energy and potential energy against time, it will going to the else if to the j equal to 2, since that we save that the choices is a j. For j equal to 2, we're going to calculate and then plot a double line graph. Before we calculate to plot a double line graph, we have to calculate first. We use at the same as the j equal to 1 for the graph of height against distance. The TG0 we initially let it become 0, and then TGF is the final time travel. We also use a calculation to calculate it. Same with SGF, we also use the calculation to calculate the SGF. After that, we come to a for loop. For loop, O equal to 0, and then O less than n means that O need to be less than 100, and O++ means that every time looping, O increase by 1. For TGO, this one is an array, and for the looping, we're going to save from the initial 0 until save until the n TGO until n 100. Okay, for the next one, KG array KGO, you also need to use a formula to calculate it. After that, you save it as the O increase. Same with the HGO and PGO and TGO. All these are using formula to calculate it and then save it in the array. To plot a double line graph, we cannot use the plot XY just now as height against distance. We need to plot it manually. So that we use plot title. It means that the title of the graph, potential and kinetic energy plot. Plot label, plot axis X, means that the name of the x-axis, we look at it as time second. Plot label, plot axis Y, means that to label the y-axis will become total energy joules. Okay, for now, we're going to plot for the line. Plot data 2D curve TG, KG, N, means that we use TG as a x-axis, KG as a y-axis, and N is a number of points. So that for the graph, we're going to use kinetic energy 0, means that we're going to name the line as a kinetic energy. For the second line, we use plot data 2D curve TG, PG, N, means that TG is the time for x-axis, PG is for the potential, which means used as the y-axis, and N is a number of points. For plot legend, we name the second line as a potential energy. And then we plot a third line for the user to compare. we use the TG, and the capital TGN means that the time travel and the total energy at the y-axis, and the number of line means that 100 for the curve. Plot legend total energy means that after that we will show a line which indicate total energy. After that we use plotting, means that you're going to plot the graph so that user can see it. Let's say at the first the user select a wrong input. You're going to go to the else, means that if the j is not equal to 1 and j not equal to 2, you're going to print f invalid input, and then need to please enter your choice again, means that need the user to reselect. So that we put a scanf at here so that the user can re-enter their choice. After the user re-enter the choice, we're going to go to hi, means that we'll go back to the choice after the scanf d, means that after the choices of the graph, you're going to choose which graph going to calculate and going to plot. After completing the graph, we print f. Do you want to end the program? And then we print second line. Enter 1 to restart program or 0 to end program. And then you put a scanf. Use specifier d and locate at loop. Means that if the user enter 0, you are going to end the program. If the user put 1, you will go back to the top to the first choices of the specifier d at the C here, so that the user able to recalculate for the choices of displacements, height, potential, and kinetic energy. After the user specify, if he or she use enter 0, you'll end the program. And then this is our program. Thank you.
Alright, people. Let's now test the program. Okay, we are given a question here, a samples question. A soldier fires a cannonball of mass 2 kg at the angle of 30 degrees. The cannonball moves at a velocity of 20 meters per second and reach a distance d at time t. Now, calculate the time taken t for cannonball to reach distance d, hence find distance d. The maximum height of the cannonball along the motion, the kinetic and potential energy of the cannonball at its maximum height. Now, with the program, start the program, and the program will prompt you to insert the input. Now, let's input mass, which is 2 kg. Then we insert the velocity, which is 20 meters per second. Now lastly, we insert the positive degree acute angle of the projectile in positive value, which is 30 degrees. Now, what we need is to find the time taken t for cannonball to reach distance d. Now, and then we need to find d. In the program, press 1 to find the displacement of the cannonball. Now press 1, enter. You will be given the furthest distance of d, which is 35.311943 meters, and the total time travel will be 2.039 seconds, which is needed by the question, and you can find your data. Now, you can plot a graph if you want. Oh yeah, if you want to plot the graph of displacement against height, you can plot the graph. Press 1 for plot the graph, and choose graph of height against distance. Press 1 again, then the graph of height against distance will come up. Now we start the program. To find another unknown, you press 1, enter. Now the program will prompt you to find another unknown. Now need to find the maximum height of the cannonball along the motion, which is the height of the cannonball. Now we choose 2 and press enter. We got the maximum projectile height as 5.096840, and it was shown in a table form with time increasing at 0.1 second each time. Next, for the next question, we need to find the kinetic and potential energy of the cannonball at its maximum height. Now, we do not want to plot the graph, press 0, and we restart the program to find the potential energy and kinetic energy. Now press 3, enter. We're given the potential energy throughout the motion, and now we can plot a graph to give us a clear visual of how the potential energy and kinetic energy varies with time. When you press 1, you press 2 to get the graph of kinetic and potential energy against time. Press enter. The graph will be shown as this. The red line will be the kinetic energy and the potential energy will be the green line. The total energy is the blue line that add up both kinetic and potential energy. Now you need to find the kinetic energy. You close the graph, then the program will prompt you to restart the program or end the program. Restart. Press 1, enter. Choose kinetic energy, press 4, enter. Then you will get the kinetic energy of all the values. Right now, all the question is answered, so end the program. No need to plot the graph, 0. End the program, 0. That's all. Thanks for watching.